So in this video, we'll talk just a little bit about some of the chemistry core concepts and how they're going to apply to this particular project. As you can see from our diagram, we actually have 5 different ones that we'll be looking at. Now, the chemistry core concepts, they are explanatory and generative concepts that are fundamental to chemistry. And so they really underlie much of what we experience in the general chemistry classroom, whether that's at the high school level or at a college level. It turns out that a team of chemists at MSU identified what they viewed as 4 core ideas for chemistry, and those are really focused at the undergraduate level, and those are 1 through 4 that we have listed. And then for this project, we're adding a 5th, and that really focuses on the idea of the particulate nature of matter. So when we think about the chemistry core ideas, there's a few things about them that we want to keep in mind. First of all, they are these broadly applicable underlying concepts that explain a really wide range of phenomena. So they're the kinds of things that we'll see come up again and again throughout an entire course or 2-course series, but also across multiple different courses. So if we think about general chemistry, organic chemistry, etc., many of these same things are going to come up. One thing to realize that they are not really, though, is they're not just the ideas, they're not normally just ideas contained within a single chapter of a textbook. So if we think about something like equilibrium, that's not likely a core idea, right? That's not quite big enough of what we're looking for. One of the things to realize is that the core ideas, almost all of them will appear in almost every single chapter of a textbook if you want to sort of think about that unit, that each of those have different ways that they might operate and come around in that particular space. So we also need to think, what does it take to actually be coded as a core idea when we're watching these videos? When is it present? When is it not? So one of the key things here is that the core idea must be explicitly tied to the explanation of the phenomenon of interest. Now, I used explicitly in quotes here because exactly how explicit, that's really one of the big questions that we sort of fight with this. And that's what always creates a little bit of the gray area in this, and that's where some of the discussion comes in. And this is one of the reasons that we typically have multiple people who will be coding a single video and then coming together to talk about it, so that together they can come to a decision of, was this explicitly or not explicitly enough tied? The really important thing when we think about it, though, is that the core idea really needs to be accessible and evident to the viewer or to the student who's looking at this particular video. Okay, so that's why it needs to be explicitly tied. As an expert in chemistry, you may be able to look at this and dig down far enough and see that electrostatics and bonding, of course, are present in almost any topic, right? Or that energy is really underlying what's happening. But if that isn't made explicit within the context of the video, then it's likely that that's actually going to pass right over the head of many of the people who may be watching the video. So that's part of the reason that we're looking for that explicit piece. One could easily imagine thinking about it in the context of this particular question, of what happens to the pressure if we increase the temperature of a sealed container of gas. In this space, increasing the temperature would make the molecules move faster, they would bump into the walls more, that would increase the pressure. But you could imagine, right, that someone might just say, oh, well, when we increase the temperature, well, the pressure is going to increase, with no actual addressing the actual core idea of what those molecules are doing, what is it about that particular nature of the matter and how it's interacting that causes that change. However, if you did say, well, we increase the temperature, therefore the molecules move faster, they're colliding into the walls more frequently, now we might be starting to bring in that aspect of the particular nature of matter. What is it that the molecules themselves are doing? Or better yet, maybe there would then be some sort of representation of this, right? Where we could talk about how, well, these slower moving molecules, because they're at a lower temperature, are going to collide less frequently with that wall, as opposed to these faster moving ones, right? Where we can see that there are more collisions that are happening with the wall, right? So those second 2 examples might be ones where now we've made that explicit connection in a way that, again, was always there. If we just say, well, we increase the temperature, so the pressure goes up. But if we're not making that connection for the viewer, then we're really not going to code that as a core idea. So as you're looking at this, again, there are 5 different core ideas. One of the really nice things about our project is we hope to always be able to provide you with some explanations of how we expect that these core ideas might be expressed in the videos. But if they're not, or if you hit a situation where you think maybe they are, make sure that you flag them and we can have further conversations about that.